Welcome to the first session for learning C programming. So this is the first program that you're going to learn. This is how a C program looks like. Normally what happens is you're told that the first line of the code has to be hash include, the second has to be void main, and whatever has to be written in void main. But have you ever thought, why do you exactly need hash include? Why do you need a void main? What is the meaning of stdio.h? Let us start with what is hash. It is known as preprocessor directive. Now preprocessor directive will be explained in the next few slides, right? All you need to understand here is you're using it because you have to include the file stdio.h in your program. Now include is a keyword. Keyword is a word whose meaning is already known to the compiler. You don't have to tell what exactly is meant by include. As soon as you write include, the compiler will understand what it has to do. The next is stdio.h. It stands for standard input output. Printf, the function that you write for printing something on the screen, is included in this particular header file. Now how do you come to know that it is a header file? Because of this .h extension, right? So all the functions that are related to input and output like printf, scanf are written in stdio.h. What is void? All the functions that you write in your program need to have a return type. It can be either integer, character, float, or if it does not return anything, it has to be void, right? So as of now, all you have to remember is you'll keep the return type as void for main. Now what is main? It is the function from where your compiler starts finding out errors, or basically from where your compilation process begins. Now before I move further, I would like to ask you, how many main functions can you have in a particular program? One? Right. Now why do you have only one main function in your program? Because the compilation begins from main. If you have more than one main function, the compiler will get confused where it has to start compilation process from. Okay. Now printf is a function whose meaning is already present in stdio.h, and that meaning says that whatever is written within the set of brackets within double quotes will be printed as it is on the screen. So the output of this particular program when you type it would be my first C program. So whatever you write within double quotes will be printed on the screen as it is. So what all we are going to learn here is, one, what is preprocessor directive, then what do you mean by a header file, then what is the difference between angle brackets and double quotes. Normally we write stdio.h in angle brackets. Now what if I write it in double quotes? Would it be right or wrong? Okay. Then what is data type? What do you mean by main? What is void int? What is a variable? What is printf? And what is scanf? Preprocessor directive, as I told you, it begins with hash, right? And only white spaces are allowed before preprocessor directive, nothing else. So all these statements, whether it is in C or C++, right, is terminated by semicolon. But preprocessor directives are not considered as statements, so we do not terminate them. So these statements are processed before your compilation actually starts. Now there are two types of preprocessor directives. One is hash include and the other is hash define. In this presentation, I am going to explain only hash include. So hash include is again of two types. The first one is when you write down the name of the file within angle brackets, and the second is when you write down the name within double quotes. The only difference is the difference in the location where the file is searched. Now what is a header file? These are the files which contains the prototype of the functions, right, which are predefined. For example, the header files like ctype.h, float.h, stdio.h, string.h, all these have a set of functions which are already defined. Alright, now coming to the next program. Now what is int? It's a data type. Now what do you mean by a data type? A data type is going to tell you the following things. The first is what type of value you can store in a variable which is of a particular type. For example, if it is int, you can store numbers in it. How many bytes in the memory that it can take? Int would take 2 bytes. The range of values that can be stored, right? The different data types are int, float, double, char, and so on. The first statement that I've written here is int a, b, sum. Now this is a declaration statement. We are declaring that these variables are going to take the data type int. Now this a, b, and sum are known as variables. Now what are variables? Variables are a portion of memory, right, where you store your values. Now why are they called variables? Because the values that you store in them may change. At a time you may store 5 in A. After a few lines you can also change the value to say 10, right? So the next statement, A is equal to 5, is known as initialization. The value that you allot to a variable for the first time is known as initial value, and the step is known as initialization, right? After this particular step, if you assign the value again, it would be called assignment, not initialization, right? So here we are initializing the value for A, then we are initializing the value for B, and then we are adding both the values and storing them in the variable sum. Now printf is used to do two things. One, to print any message that you write in double quotes. Secondly, it can be used to print the value of a variable. So this sum is going to print the message on the screen, and this %d is going to print the value of the variable that you put in here after comma, and this is known as format specifier. Now this is dependent upon the data type of this particular variable. Now, since the data type of sum is int, the format specifier used here is %d. Similarly, had it been float, it would have been %f. Had it been character, it would have been %c, and so on. So the output would be sum is, and the value of sum is 10 plus 5, that is 15. Now let's start programs. These are the simple programs that you're going to do now. You're going to print hello 5 times. Then you're going to try print hello in multiple lines. Then you're going to print hello in the same line with tab spaces, right? Alright, I'll give you a hint. For multiple lines, you have to use /n. For tab spaces, you have to use /t. Now, how do we go about writing a program? Normally, what we do is we think whether we would have a printf statement or a scanf statement, or would it be like int a, b? How do we do it? The first step is you have to think in your mind, independent of any programming language, what you have to do, right? Whether you have to print, or you have to read from the user, or you have to process something. After that, you're going to think of the syntax. Like if you have to print something, you'll use printf. If you have to read something from the user, it'll be scanf, and so on. Now, how do you save your program? In C programming language, it is with .c extension. Similarly, for C++, it would be .cpp. You can also use F2 to save your program in Turbo C. Then you have to compile your program. That is, you have to check if there is any error in your program. So you'll be pressing Alt plus F9 to compile. Then you would link it to the memory, and then you would run it. And finally, if you're not able to see the output, you will press Alt plus F5 to go to the output window. Now, what do you have to do? The first one, it's a very simple program. You have to add two numbers. You don't have to read anything from the user. You just have to declare two variables, initialize them like we did in the last program, and then print the result. The second would be you have to read the values from the user. and then subtract them and then print the result. So how do we master programming language, whether it be C, C++, .NET, Python, anything? Then as the number of programs that you create increases, right, the more time that you spend on programming, the higher is the level of mastery. Alright, so all you have to do is practice, practice and practice until and unless you write the code with your own hands, you're not going to remember it. So for any questions that you have related to this particular slide or any other question related here, thank you so much for your time and patience.